Lesson 3, Equivalent Circuit. Section 3.1, Output Characteristics. Experiment 3.1. Construct this circuit. This experiment is to measure the effect of varying VCE on IC. Set VCC equals 2.5 sine omega t plus 2.5 volts. Measure VCE and VCC with the parameter VBB equals 800, 900, and 1000 millivolts. This is a snapshot of the oscilloscope in ADALM 2000. The horizontal axis is time and the vertical axis is voltage. The orange curve is VCC and the purple curve is VCE. In this case, VBB was set at 900 millivolts. From the saved data of VCC and VCE, IC was calculated. This graph shows the obtained IC-VCE characteristics. These IC versus VCE relationships are called output characteristics. For example, when VBB was 900 millivolts, IB was almost constant at 2.5 microamps. Let's focus on the orange line in the region where VCE is higher than 0.4 volts. In this region, as VCE increases, IC increases slightly. This dotted line is an extension of the output characteristic. If VCC becomes higher than 5 volts, then IC moves along the dotted line. This is the load line in section 2.5. This load line was obtained from the transistor circuit with VCC equaled 5 volts and RL equaled 3.3 kilo ohms. In this transistor circuit, if IB is maintained at 2.5 microamps, the circuit will operate at the crossing point, which is called the operating point. In the same transistor circuit, if IB changes, then the operating point moves along the load line. Again, these are the experimental IC-VCE characteristics. Each IC line has a slight slope. If we extend these slopes to negative voltages of VCE as in this figure, then, they cross the horizontal axis at nearly the same voltage, approximately negative 100 volts. This voltage is denoted by negative VA. This VA is called the early voltage, named after James Early, who discovered this phenomenon. The early voltage of the 2N3904 transistor was approximately 100 volts. The phenomenon that IC increases with increasing VCE is called the early effect. Exercise 3.1. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.